Okay, hello everyone. We are here for a design review of spatial statistics for upcoming version of Wolfram language. All right, this is the first time I've looked at this project, I think. It's been going for several years, right?
Yeah, it's a meaty topic. I expect us to have more than one meeting. There are two guide pages. There are two views. There's sort of the data view and there's the model view.
Okay.
Kind of like in statistics, you have distributions, which are models, and then you have sort of data, just points basically, and observations.
Right, okay. Okay, all right, so let's take a look here. Spatial point patterns, is that the one I want to go to?
Yeah.
But is that, okay.
So we've gone to some lengths to not call them point patterns. We're going to change the name probably for that guide page too. Because we figured that calling them, even though that's what they regularly called, in our language, that would probably lead to unbelievable confusion.
Yeah. Okay, so this is...
So can I just, to just orient just the slides? Okay, so the thing that we study in this, there's sort of two big chunks of spatial statistics and probability. So one, which is this one, where we study a point pattern, which is a collection of points, and that might be galaxies, it might be trees, it might be cells under a microscope.
Yep.
It might be crime location, it might be disease locations.
Okay, I get it. Yep, I understand.
Okay, the other branch, just to mention it, even though we're not covering that here, you're studying random fields, and that's kind of like
I understand. So like population density of the Earth, or the density of I don't know, temperature or carbon dioxide or whatever else on the Earth. Is that right?
Yes.
Okay.
Yes. So
and
it's
that
a continuous thing.
Vector fields and things like that too.
That's a continuous thing. So it's like random processes. For each point in time, there's a value. For here, each point in space, there is a value.
Right, but there's empirical data. That's the number one issue there, rather than models. I mean, there's empirical data about, the distribution of temperature on the Earth or something.
Yeah. So actually, in each point in space, there is a distribution. And so, but that if you think of all the value,
that's a different thing. That's a random process model.
That's what random fields are.
Okay.
Random fields are random processes.
But before we even get to that, we're to walk before we run. Right. The first thing we got to do is temperature field of the Earth, make statements about that. Time series of temperature field of the Earth, make statements about that.
Yeah.
Right. Then we've got a model for, let's say epidemiological model that predicts with probabilities what's going to happen in different, well, that's a bad example. We don't yet believe in the viral field hypothesis.
Yeah.
That says
the kinds of models in that space, which we're not doing today, are things like stochastic partial differential equations.
Yeah, okay.
And Markov random fields.
That's a running, because we're not even walking right now. I mean, the walking is, we got to be able to ingest the gridded population data of the Earth and be able to say what's the expected population of this particular geographic region with this particular set of cutoffs, given this overall random field, random distribution, right?
So
do we have the capability to do that right now?
Yeah, so this is not what we're covering today, okay? I'm just describing the two big branches of spatial statistics.
I understand, but I'm saying there's a third sub-branch there, which is the one that I think is important, and way more important than stochastic differential equations, which is way off in the stratosphere. The basic thing there is you are given, taking the example of the thing I just raised, right?
Yeah.
You're given the gridded population of the Earth, and you're told, estimate, somebody just, redrew the boundaries of country X. Yeah. Estimate how many people are actually in country X with the redrawn boundaries. Given
so in this project, we did some work on that, and I'll package that up in a way that doesn't bring in this whole total picture. And that's usually called kriging. This thing, when you want to figure out what the best expected value is, which this is a prediction. This is also known as the predicted value. So that's the conditional expected value.
Okay, but it's important that we cover these simple cases, right?
We will.
Before we're worrying about stochastic differential equations.
Yes, we'll do something small there, like that.
Okay. All right. Okay.
Post this project.
All right. So let's take a look. I'm a little bit concerned about the level of technicality of these things, given what I know is, the core issues. Okay. So let's start in on what we look at here.
Mm.
Okay. So what do I start with? Spatial point data.
You can look at that, and so that's a container. So when you collect point data, it's very important to also know.
I assume we have Jose and people representing the Geo crowd here. Yes.
No, but I can get them right now.
Okay. Okay, go ahead.
So it's important to know what the observation region is. So the fact that there is no event there is significant. You know what I'm saying?
Yep.
Otherwise, the statistics is, sort of.
So in other words, usually in a statistical distribution, the information on the range, on that it's a distribution on 0, 1 is kind of implicit and just in the documentation. But here we have to expose that as a computable thing.
Yes. So that's a region or geo region.
Yep, I realize. I understand. Okay. So this is now a little bit like a time series. This
Not
is now
quite, because it's like an earthquake. There's no interpolated value. So that's the others. Okay.
Well, it depends what it is. If it's an earthquake, there's no interpolated value. Although if it's the strain, if it's observations taken about the strain of the Earth, there will be interpolated values.
But that's not what we're doing. That's the other branch. That's why I was describing that.
Okay, I understand what this is.
Okay.
All right.
Now, the other thing that's common here is that you have annotations for these observations. So if they're trees, you know some other properties like diameter at breast height and species are two very common things.
Yeah. Okay. Fine.
So they're usually called marks. There are other things that you can have.
These. Yeah. Okay. Go ahead.
Yep. There are other things that you can know, and they're usually talked about as covariate or input. There are things like elevation.
Right, I understand. So there's a big bucket of potentially an association of properties associated with every point.
Yes.
Right, I understand. Okay. All right. So now what do we do with this? So first thing we might want to do is visualize it. So for instance, if I want to visualize it showing just the density of trees in a particular region, what would I do? So in other words, is that just geohistogram?
If you just want to visualize then there are various ways to do that, like geohistogram, geosmooth histogram, and so on.
But what about if I just want the points? If I just want to know what were the geopositions in here? The kind of the analog
point value plot is the universal plot function for this.
Okay.
And it works for both geo and non-geo.
Okay, so then what we're talking about here, okay, so by geo, the way we're tagging geo is that the points in here have either just coordinates that are just lists of n coordinates, or we have explicitly geo positions as the point position, as the descriptions of the point locations. Yes, is that right?
Yes.
Okay.
Hello, Jose here.
Hello there. We're talking about spatial statistics, in case you can't tell from the title.
Right.
Okay, selecting subsets of data and annotations. Okay, so I mean, I'm just trying to understand here. Well, okay, let me just keep going with all of these things. Okay. So that's just a function applied to the payload of every point. Is that correct?
Yeah, but you might also want to select you might also only want to select the point that is in this part of your space.
Right. So how do you do that?
You have this criteria function.
But I understand. But one
Hey,
criterion.
Oh, there you go. There's a table below there. There's hash point and go down. Go down. Hash point and hash key.
Why is that key lowercase k?
Because they're defined by.
Oh, I see. That should have been an italic key.
Yes.
Okay. Okay. So this is what you're doing here is you're assuming the payload is an association, and you're adding a faux additional element to the association, which is the actual coordinates of the point. Is that correct?
Yeah. I mean, that's not part. They're not in the association. They're just points.
No, I understand. But what you're doing is syntactically, it is as if there was.
I guess you're right. I guess you're right, actually. Yes. Yes.
Okay. Yes. So for example, one thing you should obviously do in the ingestion of spatial point data is to allow it to take a list of associations that contain point as an element of the association. Am I making sense?
Yes, probably we should do that. Yes.
Right. So then it all becomes consistent. And what you're saying here is there is a point thing that is effectively added as an element of the association. If you have your own point value, then I don't know exactly what happens and what takes precedence. Gosha, maybe you can say something about that. Is that Gosha? Is this Gosha's project, or who's
yes. Gosha and Eduardo?
Okay. Okay. So can somebody say something about that, please?
What was? Could you?
Okay. Please pay attention. This is your one meeting that we've been in together in forever. So please pay attention. Okay. Roger, can you repeat the question?
So Stephen suggested that we should accept annotations with point as one of the keys.
Right.
Okay.
Okay, so then I'm asking, if you specify, if you have a key that has the name point, what takes precedence? If you've specified hash point, do you understand what I'm saying?
Yes, I'm just thinking because you can, you give the set of points and then it's the matter of agreeing on what we want to take the precedence for. So,
no, I understand, but I'm asking right now, have you thought this through? Presumably you have.
No, right now you have to separately input the data and then any addition, the data points, the locations, and then everything that is additional information has to be separate from that. So, like you give the points and this is the locations.
I understand. And
then it's separate.
I'm asking in this selection function, what you're doing, which I'm not necessarily a super big fan of, is you're letting the selection criterion basically sample either payload, elements, or the position, correct?
Yes, I understand the question now. So basically, if you give the point and there is an annotation which has the point as a key, it would take the point as the location.
Wait a minute, the key in the association or the original value of the point?
The location.
Okay, all right, fine. I'm not sure I'm totally keen on using point as the key name. Why isn't it location? I mean, or is it, or position? I mean, like we're using geoposition as, I don't know, position has other connotations. But point.
I mean, this is both geo and non-geo. Like
I realize that. I realize that.
Microscope, yeah.
Location or something. Okay, in any case, okay, so but basically the point here is, as we talk about points, the point of talking about points, etc. In any case, this is basically a select that's happening. So on a time series, what's the analogous function?
So you can do the time series window to select based on the timestamps, and for the selection on the values, this is on the oncoming feature. So that would be just a select that should work on the values.
Okay, so hold on. So in time series, we plan a time series select that works on values. Is that correct?
I think that it would be maybe possible to just extend the select to work on time series with the assumption that it would take into account the selecting based on values.
Okay, hold on. So in time series, we have the exact same issue that we have here, right? We have the payload values and we have the time location, right? And selection could depend on both of those things.
Time series are continuous curves,
Exactly,
so we have to be very careful.
Event series.
Okay.
If I may, can I just comment one thing? So why point and not location? Because we are selecting based on the data points and not the location, which can be any point within observation region. This is how we distinguish, because some of the statistics are based on, for example, distances between the points or between any location in observation region to a data point. And therefore, that's point, to distinguish between the location, which can be arbitrary placement in the observation region. But point is the element which exists in the data set.
I think I understood that, but I'm not sure I understood that. You're saying location is something where, for example, if I'm trying to sample what is the inferred value at this particular position, you're thinking of that as a location as opposed to point, which is something which is one of the elements of the data set.
Correct.
Yeah. So for instance, you can ask the question, given a location, what's the expected number of points
within a certain region? Yeah, I get it.
Yes.
Okay. So again, I'm coming back to, we need, commonality with what we're doing with time series. So are we imagining a time series? So it sounds to me like select itself is going to have a hard time working for time series and this geo case, because it has, select doesn't know, like if I say select and list, there is no version of select that's like select indexed, for example, that also pays attention to the position in the list. Do you understand what I'm saying? We could imagine a select index that, in addition to having a criterion applied to the values in the list, also has something coming into the selection function that knows the position of the elements in the list.
Yeah.
Right? We don't have that functionality.
Yeah, but the thing with these composite data structures, so these data structures, like spatial point data, are very effective in aggregating potentially very big data as a one thing.
Yeah,
that's efficient to deal with.
But you're not addressing my point here. But go on. Yes.
No. But what I'm saying is that we create this is a very simple query function that allows you to filter out.
Yeah, that's all good, Roger. The point that I'm making.
But there is not a big other API to these yet.
Okay, I understand. I'm saying there are three cases and they have to be consistent, right? There is select, which has no way to to put the position into the criterion. There is time series select, and there is your spatial point select.
Position doesn't matter that much for these.
For which?
For spatial point data.
I'm sorry. What position doesn't matter much? What are you saying?
The position. The position in space matters, but the position in a list doesn't matter.
No. You're not getting my point. There are three analogous situations. Okay, think about the select function, right? So Gosha had said maybe we want to extend select to work on time series. Right? Remember you said that? Yes? A couple of minutes ago? Right. Okay, so then the question is, why not extend select to work on spatial point data as well? Okay, answer, because we need to know not only the values of points, but also their locations, right? Make sense? Yes, Roger?
Yeah, I don't particularly want to extend select to work on this. I mean,
I'm trying to explain design consistency between three things, right? Which we have to be consistent, right? So what I'm saying is, in the case of both time series and spatial statistics, we believe that the selection criterion matters. It cares where the point is, right? Which we think doesn't really matter with select itself, right? Am I making sense? Yes? Did you get it, Roger?
No, I don't get it.
Okay,
so I think you're confusing two. I mean, when you say
I'm not confusing anything. I'm not confusing anything. What I may have confused you, however. When I say okay, let me use the term index and let me use the term location.
Okay, better.
Okay, all right. For select, one could imagine including the index along with the value.
Absolutely. We
criterion.
don't, but we could.
Right. Okay. For both spatial point data and time series, you expect to include the location. You are making the point you don't care about including the index, and I agree with you on that. Do you understand what I'm saying?
Yes.
Now, on the other hand, by the time we are including the location, we could include the index just as we do in nearest, for example, right? Now, I think an analogous design is what we've done with nearest, right? Where in the case of nearest, let me remind myself how that works. Okay, possible forms. Oh, I see. That's for the output, right? Is not for the input.
Right.
Okay. All right. So the point that I'm making is we need consistency of design between time series select and spatial point select. And we have to decide we're really going to have those two different things. And I think the answer is probably yes, right? To deal with those two cases. Am I making sense? And the reason that we want those additional things is because we want to have we want to have a criterion, and a common criterion might be region within Q, for example, for the hash point value. Is that correct? Is that correct? Am I making sense? When you say spatial point select, right? You say, I want to only pick the trees that are inside the national park, for example. Is that right, Roger?
Which is member. Region within is 2 regions. Okay,
fine. Region member Q. Yeah. Okay, but am I correct that that's the code fragment that you're expecting there?
Yeah.
Okay, is that always the code fragment? In other words, are there other criteria that you might seriously apply to point other than region member Q?
Yes, you can use any algebraic notation you want.
I understand, but like what?
The part 1 can be greater than 1. Part 2.
I'm well aware of that. I'm asking realistically because I'm asking about this design, because what you're saying in this design is that you're putting in, you have this thing that I think is a little bit hicky, which is this thing where, you're saying there is an association which gives the values, and then there is a special key that you're using to indicate something which is a value that comes from somewhere else, right?
Mm-hmm.
Okay, so I'm also saying that if I look at spatial point data where you have a region that defines the whole region of interest, I'm kind of confused. I'm kind of wondering whether there is a cookie cutter that you might want that basically is a spatial point select where you just give it a region.
So spatial point data accepts a region, and it does just that.
No. So you're saying if you nest spatial point datas, they will cookie cutter each other. Is that correct?
Yeah. If you have spatial point data.
No. You understand specifically the scenario I mentioned. That is, you have.
Yeah. No, we have a thing for that. Okay.
Okay. So
because that came up because that became another thing that didn't fit here. We had a hash region equal to, which is not,
Okay. Fine.
This is conceptually, right now, it's conceptually an analog thing to select.
Okay, let me go back. Let me go back
paragraph.
Again. Yep,
if I have region as another thing, it becomes not conceptually the same thing.
I got it, Roger. So I'm asking my specific question, which is what I would expect is that spatial point data of what you've got there is spatial point data of the point data, comma a region. That if you want to take, if you've got a map of Illinois and you want to just select the trees in Champaign County, that what you would do is to say, you've got spatial point data of all the trees in Illinois, if there are any, which there are some at least, and then you would wrap around that spatial point data, say of percent, so to speak, comma, region that corresponds to Champaign County.
And that's exactly what we made work.
Okay, fine. That's what I would expect to work, and that's what I think should work, and that's all good. Okay, so let's come back now to this selection thing. So again, the thing that I'm pushing is, if we do this, we have to do it consistently in time series select. Am I making sense?
I don't know of a function called time series select.
I know. I'm telling you. Okay, Gosha just explained that there was going to be a function.
We haven't talked about that, so I don't really
understand, but I'm saying that we're signing up for something where it has to be consistent, right? So we have to think it through so that we don't make a mistake here that we can't continue there.
Yeah, but time series is the field case. This is not the field case. Time series corresponds to random fields.
Okay, fine. Event series.
Yeah.
Okay. Event series select. But now what I'm expecting is that it will actually be the same story for time
event series can be completely analog to this. Event series can be completely analog. The continuous thing is just not.
Okay, so let's look at that for a second. Okay, so in spatial point select, if we have a continuous field here, right? Not the stochastic partial differential equation, just the data, right? Just the data case, and then we want to say select in that field, right? I could imagine, then the point could be, I don't know, if it's more northerly than this and the tree is this type, then do this. And I don't see a reason why the continuous case wouldn't work exactly analogously to the discrete case. Am I making sense? That is, in the continuous case, I assume you have a function that each one of those elements of the association is a function of position. Where position, by position I mean location here. We're not. I
don't see how that can work, because are you selecting the curve? Let's say time series. Are you there's a curve coming along with it, okay? And you're addressing the points. Let's say you pick the points that are below a certain value.
Mm-hmm.
You're gonna pick a subset of point, a disjoint. There's gonna be a disjoint, curve pieces that you pick out. If you're doing that by value.
Sure, absolutely.
It's like picking out a strip in a plot.
Absolutely, it's like a contour map. It's like a contour plot.
Okay.
Right, the contour plot, you say, I want, this set of things that I'm going to color blue in the contour plot that are the things below sea level or something, right?
Mm-hmm. And the points are just, you have to actually compute what that curve or surface in the case of a field is.
Absolutely.
And that means that you're probably going to have to add more points.
Absolutely, just as you do in a contour plot.
Yeah, so you're probably going to have to add the edge points.
Yeah, so it's like list contour plot.
So that's not at all like this case. At all. It's nothing like this case.
Let's understand that for a minute, okay? This case that you're describing here, right, that has no additional points being filled in is just like a syntactic select.
Exactly.
Yeah.
It's actually the analog of select. The other thing isn't a fucking select.
Okay. All right.
If we insist on that consistency, it's not there.
Let's understand. Let's go back and understand that, right? Because in the case of a continuous thing, you are going to want to select. Okay. So here's a question. Okay. So what I want to do is I want to draw a picture where I want to color red every place where the level of where the density of lizards is greater than such and such, right? And I measured certain lizard density in certain places, and I imagine there's a lizard density field, right? So of our various functions, what is it that allows me to color red there are more lizards in this area? In this area, there are more than 10 lizards per square meter or something.
So then you derive a field. Okay, so that's what's called the intensity here.
Mm-hmm.
You can either do it directly in your, in the graphics in the plot functions, because we have capabilities of doing that, or you get the function, which is called intensity, or the point intensity, and then that's a derived field. And now you're back to doing whatever you want with a function that you want to color a certain level.
Yeah, but you've got to feed it back into whatever the base coordinate system is. That is, if it's geocoordinates, whatever. Okay, I understand.
Right.
Actually, there's an interesting comment on our live stream here, which is talking about part syntax and the somewhat exotic idea that what would happen if, I don't know whether we could do this, but what would happen if we extended part syntax to allow keys that could sample things in things like time series? So for example, normally in a time series, we would say, or event series, whatever, it doesn't matter because it's the same in both cases here. Okay, so we would say something like, we have a series and we would say element 6, for example, okay? Now a question would be, this is probably crazy. A question is, clearly we have things like spans right now here. The question is, this is probably crazy, right? It's probably crazy. Never mind. Something like this. I don't know if this makes any sense. I mean, the issue is you're trying to, in a time series, you're trying to get at something which is not, we need a consistent way to get at essentially this base quantity, which in the case of an ordinary list is its index. In the case of something like time series is the time. We need a consistent way to do that in functions whose primary objective is to do things based on values. Does that make sense? And it would be nice to have a way to handle that that would work. I'm thinking about this in other words, imagine that there was a symbolic thing that, let's imagine, not a very good name, but let's imagine something like base value. Let's imagine that symbolic construct, and that symbolic construct could occur in, no, that's not a good name, but that even in select, you've got some list, okay? That somehow that you could do something like this. This is a bad, this particular syntax is no good, but
you mean you mean the analog of position in this particular case, right?
That's, or index in this particular case. Yes.
Yeah.
Right. But I mean, so what I'm saying is a standardized way to get at, I mean, this is the analog of something. I mean, this would be an interesting way to do this because, right now, and for the last 30 years, we've had, the map indexed mechanism where we say, where we have something like this, where, I mean, this is a more general discussion, but where we have something like this, right?
Right.
Now, what if instead of that, we could simply say map f hash, comma, base value. And if that basically knows, right, if it's a symbolic representation of its environment.
Right.
See what I'm saying?
Right. I think we need to have this discussion
different
somewhere
group
else.
Yeah, different group. This is an ILD LCC type discussion.
Yeah.
But I think it informs a little bit what we're talking about. So can somebody who's PMing here?
Chapin, I have a note to add it to an ILT meeting.
All right. So that leaves this a little bit up in the air, this hash point thing. It's I get what you're suggesting. It seems okay. I think there might be a better general mechanism. Okay, so let's look here. So is this newly added?
Yeah, it's not fully added yet in the sense that it requires this new object to represent them, so it can't be sort of live, obviously.
No, I understand. So, but this is something where you've got archaeological sites or something here. Cool. Okay. Yes. Okay. So then this is going to bring back, this is nice. Okay, so this is then a for spatial point data. Those are certain. The summary thing is a sample here. Yeah, this is obviously not consistent, right? Set count is a.
Yeah, we've changed. This is
so
this is going to get updated to
okay, fine. So it should just be the usual thing that we do for these. It's just lowercase explanatory output type stuff, I think. Maybe not. Maybe I'm wrong about that. I think what we normally say is data set or something there. And that would be some kind of thing represented as a data set. And summary would be something that's more human readable.
Yeah. We haven't seriously looked at this particular aspect here. The big thing was to get sort of enough interesting kind of data sets, because a lot of them are.
Yeah, it's great.
You know.
Okay, so lots of good data sets of point data. All right, so now we've got these other functions here, and I'm not going to have a chance to go through everything as you predicted, Roger, here. Oops.
This is a meaty topic. I mean,
yeah, okay, I understand. I know you've been working on this for what, 3 years or something?
Yeah, it's been on and off, but you know, but as I said, it's a hard topic and it's a slightly meaty topic.
Okay, all right. So, but okay, I can't find this mean intensity thing. Is that something I should be able to find? It says not found.
Okay, my bad.
Okay.
Or mean point intensity now.
Okay. Thank you.
But I'm not sure if we have a.
Okay. Okay.
This is the simplest model, you know, so with a constant.
Okay, so this is mean point intensity means number of points per unit area. Is that correct?
That's correct.
So if I do this on geopositions, do I get units?
That's a good question.
Yeah.
Do you get units?
Yeah, you should, because if you compute the geo area, it returns you units, then you should get the units, yes.
Okay, so here, if I take this and I say, for example, let's take this and let's say, let's do this. Let's say capital cities in Europe. Okay, hopefully. Okay, there we go. All right, great. And now we say, now, can I directly feed these to spatial point data? We should make sure that works. Right, you get what I'm saying?
In what respect? If you
so Gosha, I should have brought this up. Maybe I did. But the thing is, if that entity has a
geoposition property,
has a geoposition property, we can extract it and treat them as points.
Right.
Okay. So we do that in a bunch of other. I think we talked about this, but I didn't go back.
Okay. So if you didn't do it, you should do it. Okay, so right now that will give geopositions. Okay, so now I can say spatial point data of that, right? Okay.
But you really want, you can do that, but now you sort of, now it's going to approximate the observation region with the convex hull of those points.
Okay.
And that's not probably what you want.
Well, okay, but so if I now say mean point intensity, okay. Okay, all right. And it did miles because why? Why did it pick miles?
That's probably because we are in United States.
Okay, all right, okay. So it's a default.
It uses the same convention as geo area, or so what geo area is used.
All right, okay, fine. So now if I were to say, for example, geo area of your spatial point data, would that give me the bounding region area?
No, but maybe it should.
Probably should. Right?
So this is not going to work on a spatial point data as a whole, but you can access the region measure as a property on the spatial point data.
Okay.
Yeah.
So if you do.
Okay. So notice the point that in spatial point data here, given that this is it's not completely obvious to me what the summary blob should look like in this particular case, right? Given that we know these are that long. I mean, and it should probably say here that it's geopoints, right?
Yes, it probably should.
Instead of dimension 2, why doesn't it just say, something about geodata or something? Does that make sense? And then we could mimic this here. Yeah, I don't think we should be. I think it should be more specific, right? By the time it knows it's geodata. Make sense?
Mm-hmm.
Okay, so now if I say, let's see, smooth point intensity. So wait a minute. If I use one of these estimators, is that going to have another argument? Is that like a PDF or something? Point intensity function, right?
Yeah, they take
how do I
point, spatial point data.
Okay, how do I get something where I can show the smoothed histogram? I mean, I guess if I just say here, geo-smooth histogram
that would do.
of %2, then what I should get is interesting. Okay, that's where there are the most countries, I guess.
The smaller countries, yes.
Right. Okay, but so now explain to me what. So let's look just for fun. If I say geographics, can I do this? How would I combine the geopoint that I get from the mean I see. No, I see. There's a different thing, which is where is the mean point intensity? Right, I get it. Okay, so explain what is point intensity now?
So we've extended all of these histogram and so on functions to be able to show intensity, so they can use the same units.
Okay, but by the way, is this the randomness test? We don't call it randomness test for hypotheses, for generic hypotheses, do we?
We call them test, yeah. They're all called test.
I see. But by saying randomness test, I mean, we don't have a randomness test as a built-in thing.
But this is spatial randomness.
Okay, so I'm supposed to read it as spatial randomness in parens test.
Yes. That's what it's called. I mean, we could call it something else.
No. Okay,
yeah.
Fine. Okay.
And it's kind of a stupid thing, because what that means is basically uniform. Is what
I understand. It's like meteorites. We could test whether the meteorite distribution on the Earth is uniform or not.
Yeah, that's what this test. This is what spatial randomness means.
And presumably in the geo case, it's per unit area. Is that correct?
Yeah.
Okay, so what do some of these other things do here?
Okay, so that homogeneity measures, that's kind of a meaty part, and that's sort of second order statistics. So, all the intensity things are first order statistics. Yeah.
If I take this thing and I say of my data set here, wherever it was, of %4, and I say Ripley K, %4, the heck is that now?
Now you can plot that as a univariate function that you can plot.
So how would I do that? I would say plot this of R. R goes from, now what do I do here? What do I do here?
You have to, 0 to up to the max radius.
Okay, what is max radius? How do I get that out of this thing? Gosha? Eduardo?
Is it max radius?
Well, I don't know. You wrote it. I didn't. Okay, so that didn't work. So how do we do this? Do you understand the question?
Yes.
Yes.
So the workflow there is not the cleanest. Go to the Ripley K page and we'll see. I mean, we can always type in that number because it comes in with a unit.
No, I understand that. I get it. But I mean, so plot doesn't right now support having units in the range. Is that correct? I'm surprised by that, actually. I'm really surprised by that. Although maybe what went wrong is that the 0 doesn't have units and the upper limit does. Okay, dandy, but I want to see a geo example. Ay, 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 ay. Look at this. That was the problem, right?
Yeah.
Yeah, this is kind of a piece of hackery here. All right, so we need to deal with that in some way. Okay. All right, I think we are not going to be able to, well, obviously we're not finishing this today. Now, this stuff here, this exists, or this is coming in the future?
No, it exists.
Okay. Cool. Okay, so each one of these then, so I can say random variate of hardcore point process, is that correct?
We actually said random point configuration because one instance is basically a collection of points. Then if you can have many collections of points, you know what I'm saying? It's a different.
Yep. Okay. Yep, I get it. Okay. But now how does that relate to if I have a random walk process and I say random, I say for that, I say random, what do I say? Random variate. What is the analog of
random function?
Oh, right. Okay. So this is, so random point process is the analog of random function. Is that correct?
No, random point configuration is the random.
I'm sorry.
function.
I'm sorry. That's what I meant to say.
Yeah.
Right. That's the
we didn't want to call it random point patterns.
Oh God, no.
Yeah.
Right. I mean, there's some wording here that we're going to have to work on. But
sure.
Okay. So then,
there's a whole guide page for these guys and easy to click around.
Okay. Okay, so let's take a random thing here, Cauchy. Okay. So this is essentially a Cauchy distribution of what?
So you have a base set of clusters, which are Poisson, meaning uniform. And then around each one of those, you use a Cauchy distribution for the radial. It's for the radial component of sort of how they spread.
Can I have any distribution there? Can I just put in a PDF of anything?
Yes. Which one is that? Name and Scott, right?
Name and Scott point process. You can put distribution in.
I see. Cool. Okay. All right.
So this one, the Cauchy, because it's a heavy tail. So that's something where, often seedlings fall close to the tree. But some seedlings are very light, so the wind can catch them and they fly far away on occasion.
Okay. Like children of various, anyway, never mind. Right. Apple fall close to tree or not, or the apple sprouts wings and goes far away.
Yes. So this is modeling that kind of phenomenon.
Okay. Fair enough. But okay, but so then, let me see. So is it possible to get analytical results here? If I define a Cauchy point process here,
we try, but super rarely, Stephen. This is part of what makes it hard. None of our symbolics, none of our numerics hold up. It's mostly sort of simulation-based computation a lot of the time.
So is that this MC type stuff and so on?
Yes.
Or what?
All the way. Okay.
So we have somebody working on getting at least a WFR version of MC up and running. Okay, that's interesting. That's what needs to happen there.
Yeah. I mean, not all the simulations are that way, but it's true for an awful lot of other computations too. We just cannot, we're sort of they're very high dimensional.
Yeah, I get it.
So.
Right, because it's high dimensional because you can move every point around in the thing.
Yeah.
And that represents a part of the configuration space.
Yep.
Okay, interesting. So does this stuff work in any other dimensions? For the points?
Yeah, I think so, right? That works
cool.
In any dimension.
So for geo, if I have flying objects like satellites and things, if I were to do this for geopositions of satellites, which which have a height coordinate in them, it would just work. Is that correct?
No. So geo works the regular geopositions that we have.
No, but the regular geopositions do contain heights.
Yeah, but we don't deal with it. None of the models, first of all, generate geo. None of these generate geo. So I'm saying
I understand. The random process things are all non-geo at this time.
Yes.
So if I wanted to actually model seedlings and trees, I'm sort of out of luck. I mean, except insofar as I have a coordinate patch that is, my forest is in some.
You can simulate. Sorry, you can simulate geo. Yeah, all of this, the simulation, I mean, in the estimation works as well in geo. It's just that for geoposition, we're limiting ourselves to the surface of the Earth, partly because otherwise it's very hard to think what's the distance function.
It's literally distance. It's Euclidean distance, right? I mean, unless I'm mistaken, what you would do is Jose, maybe you can speak to this. I mean, look, this is a corner case right now.
Yes.
But what you're saying is, go ahead.
We don't have a notion of geodistance in 3D because it would depend on the path you are using. For example, do you allow yourself to go through the Earth or not?
I see. Okay, but yeah. Given two satellites, we can take their geopositions and we can make a geo position XYZ or something from those. Is that true?
Right. So if you go through geoposition XYZ, then you are purely in 3D, and then you could just use Euclidean distance.
Okay. So in the case of,
so that's how we do a lot of computations. Actually, we take it, whatever geoposition, we map it to XYZ, and we do the computation there.
So if I say geoposition of, let's say ISS, is that going to be the International Space Station? Oh, come on. This is, I think we're looking at a version that's broken here. That's surprising. Oh, worked this time. Okay. So if we say this, I would assume that it will give us the current location of the International Space Station, although this prototype build might not do that successfully. Okay, there we go. So that's now that's that long elevation time, right? So now, presumably, I can say geo, what is it called, the XYZ thing? What's that?
Geoposition XYZ.
Okay. So geoposition XYZ of this is now location relative to the center of the Earth. Is that correct?
Yes.
What are those coordinates? What is that?
So it's XYZ with respect to the Greenwich frame, say.
I see. Okay. So given this, that in principle is point configurationable, so to speak. So the satellites in orbit, in principle, could be turned into something. So presumably you take geoposition XYZ in spatial point data, right? Presumably if I said, just make a table of these, 3 of those, and now I say spatial point data of that splatteroo. How come? Guys?
Unexpected. Sorry.
Okay. I mean, but in principle, this should work. Is that a true statement?
Yes. In principle, yes.
I don't know what to do with this, to be honest.
But the problem is that the way that we look at the geo data, is working on the surface of the Earth, as Eduardo said. And so right now, when you give the satellite position, which is somewhere above the surface of the space, we don't we don't really know how this kind of going to apply.
I get it. So let's just, it's a corner case, right? So I'm not going to make a big production out of it, although generating errors is clearly not what we should be doing here. But it seems to me the obvious thing to do is if you were given 3D coordinates, I would think, Well, it's not clear what you should do. I mean, let's imagine it's pine trees on a mountain, right? And somebody from their GPS, they read out the elevation as well as the geopositions, and they entered those in the geoposition thing. You know, as you say, it's not obvious what you want to do.
Well, we right now, if you do that with the height, we basically forget about the height, and we try to look at that as a map.
This was just a bug with XY geoposition XYZ. But I think in the case of geoposition XYZ, it's much more likely that you are really talking about XYZ coordinates. And to be, I mean, it could, you know, given that it says XYZ in its name, so to speak. I mean, no, that was an incorrect emphasis, because it's just a location. Right. I mean, my suggestion would be that what we do is by default, we ignore height in ordinary geoposition.
Mm-hmm.
If you want height, convert to geoposition XYZ, and then you simply take that to be Euclidean position.
Mm-hmm.
Does that make sense?
Yeah.
And then it's the 3D Euclidean position, if that's what you gave here.
Yeah.
Now, somewhat awkwardly, there's also time coordinates here, but I think you should just ignore those. That's why you have the word spatial in the name.
Yes.
Okay. And so presumably, right. Okay. Cool. So, okay. But if I want to make a Cauchy point process in France, for example, if I want that process but constrained to France, how would I do that?
You mean simulate points?
Yeah, I want to, just like we say random, I mean, right now we have the very nice, you know, I think we have random point of, don't we allow one to just say France here?
We do.
And then say, you know, 200 points here. And then we can literally just generate, parameter free region.
So, no, but I think that we didn't, initially we didn't support georegions, okay?
Okay.
And so, but I think that we should have remembered to add georegions when we did all the geo integration with geometry. So,
yeah, I think that looks like a bug to me.
I mean, yeah.
Okay, but this will work, right? If I do that, then I can just say geolist plot and I'm off and running. And this particular thing, if I do this, what the heck? Oh, you've got a debugging thing in there. This is okay, that worked. Okay, so now, for example, you should check into this debugging, whatever that is, right? Yes, can somebody make a note, please?
Yes, doing so right now.
Okay, all right. Okay, so then here in %14,
that's
what
probably
I should
from
be
the
able,
Viz team.
But, yeah, it's probably debugging from visualization. This is a prototype build. So here, what I would be able to do for this, I could say, for example, pair correlation function of %14, and that will now give me a function. And now I could say the value of that at 10 miles. Am I right? It's a little odd. Why is it 0?
There might be no points in that scale, distances, and those distances.
I see. Okay, so let's try. How big is France? Let's say 300 miles. That's enough. Weird. Why is that? Is that because it's too big?
Probably.
Yeah.
Okay, so that's the pair correlation. That's the number of pairs of points that are within distance, within 30 miles of each other. And that tells us the effective density, given that you're at one of those points, what is the density of other points per unit area, right? That's the units of this. Okay. All right, but so there's a little bit of dealing with the fact that you've got these. I mean, I would argue that there's probably some accessor for point statistic function that removes units. Am I making sense? So that you don't have this weird stuff that basically just commits to a certain set of units and lets you just do numerical computations in them, right? So that I'm not giving 30 miles here. So I'm returning a function that takes unitless inputs. Does that make sense?
We should do that. We'd have to think about exactly which unit, or maybe specify the unit
right.
somehow.
Right,
Yeah.
exactly. Right, because then you can merrily go along and use plot and everything else that doesn't expect units in dealing with these functions, right? And it's also good for interconversion with standard statistics and other things, where eventually everything will take units, but it's not clear that you even want the units in for some of this stuff. All right, well, cool. This is really nice stuff. Let's get another meeting scheduled. It's going to take, I reckon it's going to take at least 2 more. Roger, do you have an estimate? Okay.
No, that's roughly where I'm at too. It is a lot of stuff. The good news is that you have a background, with statistical physics and other things, so you're probably familiar with some of it.
Yeah, some of it. I mean, except I've never seen, 2-point correlation function, I understand that.
Okay.
I mean, it raises questions about endpoint correlation functions.
Yeah, look, this is it won't be hard. Just working our way through it, it will be very clear.
Right. I think that the things that
just for comparison, there's an R package that they developed for 20 years that has 2,000 functions that does this.
Mm-hmm.
And I think we cover pretty well in 40 to 50 functions.
Mm-hmm. Good. I think, okay, so, I mean, just to understand, just to poke at a couple of things and then I will disappear here, like geo-region value plot.
Yes.
And does it play nice with this? I'm not thinking it through correctly, but I mean, things like geohistogram and so on, do they play nice with all of this? If I were to take here, let me take one.
Yes, and if they don't, it's planned. Okay.
They don't, because they're disabled for the time being for the prototype build. But basically,
it was just a branch problem, right?
Yeah,
okay.
But the support is there for to do the natural things for this visualization functions.
Okay, so for example, smooth histogram applied to the spatial point data obtained from this will give the same result here. Is that correct?
Yes.
Except that I could now, if I put the cookie cutter in, so to speak, and I put a region specification in the spatial point data, then my geohistogram will presumably go to 0 outside of that region. Is that correct?
Yes.
Is that and what does a geosmooth histogram do? Does it also chop to 0 outside of the specified region of spatial point data?
Well, no, because so that's not what's happening in the smoothing. You may get out of the boundary because of the kernel functions.
That's how those kernel estimators work.
I see that they have a kernel, and if the kernel is does what it does.
Yeah, if you wanna have a sharp edges, then it's probably better with the binning also, like the histogram point intensity.
Okay.
So that's
point intensity. Both of those. Yeah.
Our people on the live stream seem enthusiastic about this functionality, saying, is it coming in 12.2? Yes, it is. That's the point here. That's why we're rushing to do these reviews. Mikhail says, could be useful for some spatial clustering applications such as industrial inspection systems. Interesting.
That is interesting. That's one that I haven't heard of before. People use it to track like animal herds, like birds' nests or animal herds.
Yeah, right.
All kinds of.
Okay, Ali is saying the 2 things we really need are spatial statistics and differential geometry. Yeah, those are good areas. Okay, then Ethan is commenting, how does this fit with machine learning? Can one use spatial machine learning on this stuff? In other words, if you have a spatial point data object and you feed it to let's say, classify, what does it do?
I think nothing at this point, but it could. I mean, there's just the obvious bridge of making sure that it understands. We can make that sure happen for 12.2, that it correctly understands what spatial point data is and does what it does for point collections. Then expanding out and doing something more clever in machine learning, for that case, will take a little bit more time.
Right. I don't know whether we have an encoder for geopositions in machine learning. Do we? I mean, that knows. I mean, I don't even know. I suspect you basically have to flatten the Earth. I'll be surprised if I'll be very, very surprised if there's a neural net way of encoding, the topology of the Earth, basically.
Yeah, I mean, yes, I don't know either. But
actually, it's an interesting question. I don't even know for cyclic variables. I've never heard of those in machine learning. That is, you normally have, the concept, I suppose. Yeah, I've never heard of that. I don't know how that works. It's a good question for the machine learning team.
A lot of applications doesn't deal with the whole Earth.
I realize
a lot of applications deal with something local, like a field, like the bird's nest in a forest.
Right. Let's see, this is.
And in fact, we project, and if we have to deal with the whole Earth, there's like a singularity at some point.
Fine. So you can't do that yet. So I see. So your point here is if I were to do just for the hell of it, I mean, I could. You're saying that if I do, let me just try one thing, and then we'll Earth, oceans. So that. Okay. Okay, great. Now let's say geoposition. I assume it will give us centers of those. Okay, great. Okay, so now if I say geolist plot of this, oh, for goodness sakes, crazy bug. Okay, all right. So now, how do I see what happens in this case? So you're talking about singularity. I'm just.
I'm saying that eventually we're projecting our observation region on a plane, and the more you get to the antipode.
No, I understand that. I'm asking, what does this? How do I see that there is a problem here? That is,
it's very hard actually to see. Like you'd have to have many points.
No, but I'm asking this question. I'm asking, if I look at the 2-point correlation function here, right? Am I going to see, is the Pacific Ocean going to wrap around with a, like if I say, what's the expected number of points within radius R? Is it going to know that the Indian Ocean is?
Yes,
that's so it's going to know that wraparound.
Oh, yes.
Yeah.
Okay, good.
I mean, this led to, Jose has been super helpful. Jose has developed a lot of things here to make geocomputation, as opposed to geographics, work. And that's also led to the unification of geometry and geography. Yes. And it also led to the visualizations that you saw, the spatial visualizations of density and intensity along the route of doing this project. So that it drove many things along the way.
Right. Rich comments that one could use sine as an activation function to do the circular thing. I'm not completely getting that, but that's interesting. Yes. Bob is saying no need to flatten for neural nets, just use 3D position. It's not obvious to me that's a good idea. I mean, it's whether that's the correct set of features. Ali is asking what the center of oceans means. We have a very definite notion of center right now for how does that work, Jose? The thing that gives you the center of a region. So if I say region of, can I do this? Region of Pacific Ocean.
Well, the centers that we assign there are manually chosen. So for every geo entity, we have a position.
Why didn't this work? Sorry, why didn't this thing work?
the
I think what is prepared is to discretize it.
So what do I say here? I say discretize region.
Discretize region, and perhaps unit polygon. I don't remember. Discretize.
Okay, and then I have to say polygon here.
Right, you have to extract the polygon.
Although that workflow that I just gave probably should work. Okay, so there's the Pacific Ocean like that, triangulated.
Mm-hmm.
And so now we can obviously find the center of that.
Right,
cool.
You can find that centroid for that.
Right.
But the points that we
centroid
assign,
of that won't be on the surface.
Exactly.
Right. So then you have to project it to the surface if you want to know the surface position there, if that's what you think you mean by the center.
Yeah, that's what you think you mean.
But what I meant is that the center, the position we assign to that is just some.
It's done by hand. It's
Exactly.
not. Right. Bob is asking about clustering statistics, analyzing clusters, 3D vector. So it's asking whether you can use the spatial statistics stuff to analyze clusters. I would think the answer is yes. Isn't that part of the point? I mean, if you have 3D points, you can just use this. All right, anyway, cool functionality. Look forward to further review, and we should wrap up for now. So thanks, guys. Thanks to folks on the live stream. See you all soon.